Called the father of nuclear physics and the greatest experimentalist since Faraday, he coined the names alpha and beta particles, discovered the half-lives of elements, and found the nucleus of the atom. Here are 10 facts about the Kiwi-born Ernest Rutherford. 1. Birth and early life. Ernest Rutherford was born in Brightwater, a northern town of the South Island of New Zealand, on August 30th, 1871. His father, James Rutherford, was a Scottish immigrant who worked as a wheelwright and flax miller. Ernest's mother, Martha Thompson, was of English descent and played a significant role in fostering young Ernest's intellectual curiosity by encouraging his education and love for learning. He was the fourth of 12 children, and his early education laid the foundation for his later scientific career. He won a scholarship to attend Canterbury College, University of New Zealand in 1889, where his main focus of studies were mathematics and physical sciences. 2. Mary Newton. While Rutherford was an undergraduate at Canterbury College, he met and became very close to Mary Georgina Newton, who was the daughter of a widow of whom he rented his room. Ernest and Mary engaged in New Zealand, but Mary stayed there while Ernest moved to England to engage work at the Cavendish Lab under J.J. Thomson, best known for his discovery of the electron. Ernest held off marrying Mary until he was more established and in a good position to support a family, and on June 28, 1900, after over 5 years of engagement and many overseas letters, the two married in New Zealand and soon headed to Montreal, Canada, where Ernest had been given a chair in physics at McGill University. 3. Record with radio, albeit brief. In 1895, working under and being encouraged by J.J. Thomson, Rutherford built a device that was able to detect radio waves over a distance of half a mile, or about 800 meters, which, at the time, was a world record. However, this record would be short-lived, as the Italian inventor Guglielmo Marconi was able to achieve a sent message of radio waves over a fair distance of 10 miles. 4. Alpha and beta particles. In 1899, while conducting experiments at McGill University in Canada, Rutherford identified and gave the name of the two types of radioactive emissions produced by certain elements. He termed the relatively massive, positively charged particles alpha rays and the lighter, negatively charged particles beta rays. Rutherford's research in this area set the foundation for the understanding of radioactivity and contributed significantly to the emerging field of nuclear physics, particularly during his soon-to-come work at the University of Manchester in the early 1900s. 5. Half-lives and radioactive decay. Ernest Rutherford's contribution to the concept of half-life in radioactive decay occurred in the early 20th century. While still at McGill University, Rutherford conducted extensive research on radioactive elements. His experiments, particularly with uranium and thorium, led to the understanding that the rate of decay of radioactive substances follows a predictable pattern. In 1902, he introduced the term half-life to describe the time it takes for half of the atoms in a radioactive sample to decay. Rutherford's pioneering work in this area laid the foundation for the quantitative study of radioactivity and opened a new door for the dating of the physical world which beforehand had been shut. His investigations into the disintegration of the elements and the chemistry of radioactive substances would garner him a Nobel Prize in Chemistry in 1908. 6. The atom's nucleus. Ernest Rutherford's groundbreaking discovery of the atomic nucleus occurred in 1909 during his tenure at the University of Manchester back in England. In what is now known as his famous gold foil experiment, Rutherford and his colleagues Hans Geiger and Ernest Marsden bombarded a thin gold foil with alpha particles. Alpha particles are the nucleus of helium atoms and are comprised of 2 protons and 2 neutrons. These alpha particles were directed towards a thin gold foil, which was surrounded by a fluorescent screen to detect the scattered alpha particles. At the time, the prevailing plum pudding model of the atom suggested that atoms were composed of a spread-out, positively charged pudding with negatively charged electrons embedded in it. Rutherford's goal was to test this model. Most of the alpha particles passed through the gold foil without deflection, which was expected according to the plum pudding model. However, some alpha particles were scattered at various angles, and a few even bounced back in the direction from which they came. This unexpected result was puzzling. Rutherford concluded that atoms must have a small, dense, positively charged nucleus at the center, where almost all of the atom's mass is concentrated. The electrons orbit around the nucleus at a distance. The scattering of alpha particles at large angles or backscattering indicated that the nucleus was positively charged and that the atom was mostly empty space. This experiment was a huge step towards a clearer picture of the unseen world of the atom. 7. Rutherford's atomic model. Rutherford's atomic model, proposed in 1911, replaced J.J. Thomson's plum pudding model, in which electrons are embedded in a positively charged mixture. Rutherford's model depicted an atom with a small, positively charged nucleus at its center and electrons orbiting around it, much like a solar system. This model laid the foundation for modern atomic theory, leading to Niels Bohr's atomic model, with Bohr adding the specific electron orbital theory, getting us closer to our present understanding of the structure of the atom. 8. Discovery of the proton. The nitrogen alpha particle experiment, conducted by Ernest Rutherford and his colleagues between 1917 and 1919, seems to be the crucial moment for the proton's discovery. In the experiment, a source of alpha particles was prepared, typically using a radioactive substance such as radium or polonium, and a target of nitrogen gas was introduced into a vacuum chamber. The alpha particles were directed at the nitrogen gas target, and the collision of the alpha particles with nitrogen gas produced new particles as products of these interactions. Rutherford observed that the products of these collisions included hydrogen nuclei. His conclusion that the hydrogen nuclei was a fundamental particle arose from the fact that they were observed as individual, discrete particles. At the time, the hydrogen nuclei were being called the hydrogen particle or the positive electron, though Rutherford coined the name proton, coming from the Greek word for first, as this proton now seemed to be the first building block of all the other elements. This name stuck, and proton first appeared in scientific literature in 1920. 9. Artificial transmutation. The realization that Rutherford's alpha particle bombardment of nitrogen transmuted it to oxygen happened a few years after the initial experiments of 1919. It wasn't until 1925 that physicist Patrick Blackett, using and improving the Wilson cloud chamber, conclusively demonstrated that the alpha particles from the nitrogen alpha particle collision were transformed into oxygen and hydrogen nuclei, or protons. These observations of Blackett, which used thousands of images, provided confirmation of the nuclear reactions taking place during Rutherford's earlier experiments and was an important development in the field of nuclear physics. 10. Death and legacy. Rutherford passed away on October 19, 1937, at the age of 66 due to complications related to umbilical hernia. He was laid to rest in Westminster Abbey alongside fellow scientists such as Isaac Newton and Lord Kelvin. The synthetic element with atomic number 104 and symbol Rf, Rutherfordium, is named after him due to his significant contributions to nuclear physics and the understanding of atomic structure. He is remembered for transforming our understanding of the atom, pioneering the field of nuclear physics, and setting the stage for further advances in atomic and nuclear science. Thank you for watching. Please like and subscribe for more interesting facts about our world.